From bikes to buildings, steel is everywhere in our life. Steel is one of the most important materials in our world, and therefore, it is important for us to be able to produce steel with better performance at a lower cost. In this project, our team researched one of the ways to do so by controlling the microstructure inside the steel through a process called hot rolling. So, what is a hot rolling process? This is an important process where the thick steel slabs from the previous steel making steps get compressed into a long strip. It involves reheating the slab in a furnaces, deform the slab into a strip, write the roughing mill and the finishing mill. Cool it down to a certain temperature, write a series of water jets, and roll it into a steel coil with a coiler.
Our project focused on the cooling of the steel strip as this part has the greatest impact on the final properties. A simulation software called the hot strip mill model was used to simulate the final properties of the strip under different operational parameters. By fine-tuning the cooling sequence, our team was able to design a number of hot rolling schedules for 3 different high-performance steels. 2 of them are used to produce pipelines for the oil and gas industry, and the other one is used widely in the automotive industry. For X65 and X80 steels, our report recommends these 2 grades to be made using 2 different steels with different alloying chemistry. For DP600, we recommended that 3 additional cooling banks should be added to process this steel at a lower cooling temperature. On the economic side, we determined that it will be beneficial for the company that we work with to extend their runout table. This will enable them to produce steel with higher performance and reduce the cost of alloy elements for some steels that the company currently produces.
Here comes the important question. Why do we need to make high-performance steel? The answer is quite simple. While offering a much better mechanical performance, the greenhouse gas emission for making high-performance steel has not increased by much compared to the conventional steels. By using the steel with better performance, we will be able to reduce the amount of material needed to make different components and therefore reduce the overall greenhouse gas emissions for the production.
For example, in a world where we are confronted with increasingly severe energy and environmental crises, greenhouse gas emission from vehicles is one of the important topics today. Here is Harsh's result for weight reduction assessment on passenger vehicles. As we can see here, by replacing the conventional steel with DP600 or better steels, we can reduce the weight of a vehicle for up to 30%. Not only will this reduce the greenhouse gas emission from steel production, but also that the vehicle can be more fuel efficient as it has less weight now. Other than automobiles, oil and natural gas might be very important for us to reduce our emission while fulfilling our energy demand. Right now, more than 20% of the energy in the world is generated by coal, which is not environmentally friendly at all. According to the forecast, our demand will continue to rise in the next 30 years. As a clean energy resource, oil and natural gas can help us to reduce a large portion of greenhouse gas emission from coal, until clean energy can take over all our demand. This will be important if we want to keep the rise in global average temperature to well below 2 degrees.